All right. Um, Hello, everyone. Good evening. Thank you for joining us. I'm Ganesh Babu on behalf of Polis. I'm happy to welcome you. We hope you and your loved ones are healthy and safe. For the uninitiated, Polis is a student association for the students of Urbanism, Landscape, and UMU at TU Delft in the Netherlands. So the graduation thesis presentation series is an informal sharing space where alumni from the urbanism and landscape architecture tracks can share their research, thoughts, tips, and tricks on doing a good thesis. Today, we're doing the third episode on this series, and we have Wouter Heijden with us. Thank you for joining us, Wouter.
Thank you for inviting me.
Yeah. Wouter is an urbanism graduate from the Urban Metabolism Studio. During the Master Urbanism, Wouter got inspired by the connection between urbanism and civil engineering, especially in the context of urban metabolism. His graduation was an exploration of these topics, which integrated the quantity and quality part of urban metabolism. Currently, Wouter works at the engineering firm Witteveen+Bos as an advisor, carbon neutral, and circular design. Today, he'll be presenting us his graduation project titled City Without Sand, a material conscious approach for the urban construction metabolism of sand and gravel in the Rijnmond-Drechtsteden region. The graduation project tackles the challenges around the largely and linearly consumed construction sand and gravel within the Rijnmond-Drechtsteden region, essential in concrete, asphalt, and fill sand. The project is a design research which covers the exploration of the current construction sand and gravel metabolism within the region, a development of a material conscious urban design approach, and an application of the finding on the urban design strategy within the region. Without further ado, I would let Wouter take over.
Thank you. Thank you all for being here and to let me talk about my graduation project. I graduated last year, so it's quite recent, and I also this presentation is based on my P5, so my final presentation of my graduation. So then you know like what this is actually the end result, and it's called City Without Sand. And before I want to start with the entire story of the graduation, I want to give you a little bit of a context of my research. And Ganesh also already told about it, that it's an urban metabolic study from within the Urban Metabolism Studio. And in it, I actually combined quantitative and qualitative research. So there was a lot of calculation with it where I used GIS data in order to understand the system of in order to understand the metabolic system. And it was quite a systematic approach where I focused on one material, which was sand. Funny to mention was that during the entire year, I was always the guy who was only talking about sand. So it's nice to have like one topic, but it's also the chance that you get like become infamous about it. But also because it was quantitative, I had a measurable goal, so that was quite nice. Also, it was an interdisciplinary project, and I don't know if you saw it, but my second mentor, Henk Jonkers, is from the faculty, civil engineering faculty. It's quite nice because you get a lot of new input from his expertise. But on the other hand, if you want to focus on some things within urbanism, then there's some then it doesn't quite suit it then. But it's also good in order to get the infrastructure and environment annotation for the people who did the infrastructure and environment design electives. You can like get that as an extra, and it's quite easy to say because you just need to have like a project and discuss it with Fransje Hoijmaier, and she can say, okay, it's good and or not. And when you have like a mentor from another faculty, then it's okay. So then she will agree with it. And the project was research by design, and this these bullet points, they actually give you an insight on how I have structured the presentation. So first I will take you on the problem fields that I tackle, and also the recent question that I wanted to answer during my graduation. From that, I will give us insight on the theory behind the topic, then an analysis of the current metabolic system, and I end with solutions and applications in urban design. Yeah, as I already mentioned, the main topic was sand, and I actually started with articles like this, where they say that we are currently running out of sand, which is quite strange, because it's a material that is everywhere, and you think it's like that it can't be scarce, but apparently it is, and this quite triggered me on, okay, how can we deal with this problem, and how is it used? Because in the built environment, it's quite essential, because sand is actually used in concrete, in glass of the buildings, in asphalt of the roads, especially in the Dutch context. It's also used in building site preparation and land raising, because the soil in the Netherlands is quite soft. You need to put sand of it in order to put houses and roads in it, otherwise it will sink. And we also use it extensively in our defense against water from the sea and our dikes. And of course, sand is also part of the cementation through rivers. And this is a Sankey diagram. If you've seen more things about urban metabolism, then you've seen these schemes more often. This one actually shows the Dutch extraction and consumption of sand and gravel in the Netherlands of 2016, if I'm correct. And here on the left, you see how much we extracted. Like in 2016, we extracted almost 75 million tons of sand and gravel. Yeah, it's quite hard to get to visualize it, but I did a quick research, and you can compare it with almost 900,000 whales. Yeah, you can, yeah, if it gives that a better idea, but still it's a lot, because on a global scale, sand is after water the most consumed material on Earth. Here in the Netherlands, you can see that it's a lot of used in fill sand in order to raise your building sites, in the coastal defense, and also in concrete for the buildings. And these building materials are actually essential in urban design, in which how we design housing and neighborhoods. And and as I already mentioned, it's used a lot of use in urban development, and the Netherlands also has the challenge to build 1 million new houses before 2040, with 70% of it in the Randstad region. And that's also where my case study area is, the Rijnmond-Drechtsteden region. And this is actually the region between the Maasvlakte until Dordrecht. So it actually are two conurbations linked together, and the Rhine-Meuse estuary is an important part of it. And subsidence and land and fill sand is also important here in the urban development. And yeah, as I already mentioned, it has a certain demand for housing in the near future. But this consumption is also currently linear. So we use concrete, and when it's demolished, it isn't really reused as concrete again. It's now, it's in development, but the traditional is quite on not the real circular economy idea, which is the goal of the Dutch economy in 2050. And with that in mind, I formulated my problem statement that we want to on how we actually can achieve a circular. The problem statement is that there is an urbanization and construction in the region, which demands primary material, but on the other hand, there's also a circular ambition in the region. And I tackled this problem with this research question. How can urban design reduce the consumption of primary construction sand and gravel in the construction ecosystem in the Rijnmond-Drechtsteden region? Quite a long research question, but during my graduation, I formulated multiple research questions, and with my mentor Ulf, I discussed it on how can I tackle it the best, and so I didn't. That it was in the beginning quite flexible, but it was also a little bit of a goal on the things that I want to do. So I want to use urban design in the reduction of this metabolic system, and I also formulated these sub-questions, and these sub-questions also are in line with the method and analysis I use. So the first two questions are about how to analyze the current system, and eventually to see what this how this metabolic system works, so the LCA evaluation. Then I want to change this current metabolic system in order to reduce the consumption. And I need like certain solutions, which I summed up in a catalog of solutions. And eventually I applied those solutions on the urban design context in the Rijnmond-Drechtsteden region, and eventually see how it actually reduced the consumption of sand and gravel. And first, before I will go into this let's say analysis and research and design, I will give a quick introduction on the theory behind it. And the theory is quite essential in order to understand the system which you want to change and need to make an analysis out of it. So urban metabolism, I don't know if it's introduced before, but yes, the main core concept of the urban metabolism studio. So actually you use like the metaphor of the metabolic system, like our human body, on how a city works. So it needs energy and materials in order to grow, and it generates waste and emission in its growth. For the people who are interested in choosing this studio, it's quite you can do a lot of it, because every element in the urban ecosystem, so in our cities, is part of a certain metabolic system. But I choose explicitly sand and gravel, and also look like, okay, where it's actually used. I already mentioned it, like we use it in our cities, in buildings, in our roads, and under our buildings, in order to prepare our grounds, and in our beaches in coastal protections. And from this, let's say really specific metabolism, sand and gravel metabolism, I made this schematic and theoretical material flow analysis. So an important method in urban metabolism is the material flow analysis. And what you do is you have your urban ecosystem, your city or boundaries of your research. You have a certain stock, material goes in, material goes out, and you can do it for everything. So, for example, for human body, we eat and we breathe, and we generate energy out of it, and eventually let's continue. You can also just translate this to the urban ecosystem for sand and gravel. So you have like certain stocks where it's used, so buildings, roads, lands, and when you build something, you use concrete, sand, and gravel in order to build it, which originates from the river catchment. And when it's demolished at the end of its life, then demolition waste is generated. But for sand, when we demolish our concrete, we don't throw it away, but we use it as a foundation material in surface raising and land reclamation. Yeah, so you can see that there's a lot of input from material, but not that much output. In order to understand the system better, you need to know like when there is construction and when there is demolition. An important term in this context is the durability of the stock. So durability of a building is the what the definition says here, like how long it remains in its function or how long it stands there. There are certain factors which can alter this lifespan. So, for example, it's like standard that when we build something that out of concrete, that we say it stays there for 100 years. It's something that they standardized from the national policy. But within that 100 years, there are some things that change, that can be demolished. For example, there are internal factors which occurs over time. For example, the material degradations, when you put like when you have your building and you have wooden windows frames, then after a certain period, the material is gone, it's rotten, and you need to replace it. But there are also external factors which can cause this construction demolition event. For example, policy change or natural disasters, then it's also demolished. Yeah, and for a building, like when this actually happened, the flux, it differs per part of a building. So this is the layers of a building by Brandt, and he says like our stuff has a lifespan of 0 to 3 years, but our structure 30 to 300 years, and even our sites or our urban plan stays there for forever. So yeah, so in the city it also goes a little bit like this, but then it goes like interwoven. So the user, they change quite a lot. The function of the building also changed a lot. For example, the faculty, bouwkunde faculty, yeah, it used to be faculty for I don't know anymore, but they wanted to make dwellings out of it, but then it changed to faculty of architecture. But the building stays there for a longer period than it functions, and the same is for the structure of the public space. So there's a difference in when it get built and demolished. And this understanding is quite crucial in the analysis of when in an inflow and outflow happens in the metabolic system. So in my analysis, I actually made this schematic and theoretical material flow analysis for the Rijnmond-Drechtsteden region, and I looked at each of these stocks and checked, okay, what are the internal and external factor? And with this, I used GIS data and methods behind it in order to calculate how much material there was. I think at the moment I was the only one at the faculty who was walking with a calculator every day in order to calculate these stuff. But yeah, I will show of two of these how it's done. So but before I start with it, it's important to identify like where which, let's say, conditions or things in the urban development causes material consumption. And when we're talking about urban development, then it's densification or retrofitting, which actually requires and generates concrete inflow and outflow. But greenfield development, that there isn't any outflow, but there is only inflow of new material. So it's important to understand like how the actually to put this material flow analysis scheme onto the urban context, because most of the time there's like a gap between those things. And For other material, for example, for sand, the sea level rise or subsidence are causes which requires material, and the same for dredging and highways. But this a little bit more into detail on really how those different urban system works and when it needs material and in which period of time, and also how you will calculate it. But when we look closer into like buildings, in this part, I look at like all the buildings in the region and see, okay, and make a scenario, okay, when our building is going to be built. So when do we need material or concrete, and where in order to build it, and when will there be concrete available from demolishment? So here I use those internal and external factors of stocks and the metabolic system, and see, okay, what is the current service life or lifespan of the current buildings, and what are the policy plans which say something about we're going to build here and we're going to demolish that. But first, external factor. Here, this is a scenario of Vereniging Delta Metropole, where they say, okay, in this region, here are the places where we will there's capacity to build in order to reach this the amount of dwellings that's required in this region. And here you can see the different type of development. For example, yeah, here you see orange is greenfield development, and you know that that type of development needs asphalt, concrete, and fill sand. But for example, transformation of non-residential areas, if that happens, then there's also an outflow of materials. And here you can see how much material is required of concrete in order to develop these regions. And for the in order to make a scenario of how much material will be available in the coming years, I made a material intensity study based on GIS data, and from that I checked, okay, let's say that a building stays here for is built for 75 years. When will it reach its end of life? So here you can see like those red ones will reach their end of life, let's say theoretically in 2020, orange in 2050. And based on that, I made an assumption of, okay, in the coming 30 years, this is the amount of buildings that will be demolished, because it's, yeah, they are just outdated, and they really need to be demolished. There will be outflow of this amount of concrete, and of course you need to replace those buildings, and that also requires a certain amount of material. And then the other part of it was the fill sand, in order to prepare your building sites for urban development and also for subsidence. From there I also looked at the new constructions, those greenfield developments, but also the soil conditions. And here you also need to take in mind that the demolition waste, which was generated by the buildings, is actually used as a substitute for fill sand. So here on the bottom you can see what this actually means for the amount of material. But there's also still a demand for more fill sand, because it isn't enough to make it even. And another thing that requires fill sand is actually subsidence. So here you can see which parts are actually where subsidence occurs. So for example, this purple, pink areas, there it happens a lot. And for this, I made this actually a really rough calculations of how I calculated how much material there is needed. So what happens, here you have the data of how much paved area there is in the neighborhoods. And I used that like area with how much will be subside, because only the public space subside, because there's like a layer of sand below our roads, and that's causes pressure, which causes the ground to subside. And yeah, what actually the current maintenance regime is that we here in the Netherlands we fill it up like when it's to make it even. So for example, it subsides, let's say 10 centimeters, then we need to open the road, put more sand on it, and put asphalt on it again in order to raise it again. And that actually requires 20 million tons of fill sand for the coming years in this region. And this image shows like the results of the construction sand and gravel metabolism in the Rijnmond-Drechtsteden region for the coming years. So here you can see that what I already mentioned is that demolished concrete will be reused as site preparation, but we still need a lot of site preparation for our new dwellings. Then there's river sediment, which flows through the rivers, which is also part of the metabolic system, and also dredged material, which goes in and out. Yeah, I also calculated that, but I won't go into detail that much. But this is like a nice, visually attractive image, but there's also a more technical image behind it, which actually shows the entire life cycle of it. So there's sand which is excavated from the river hinterland, and it's used on here. It goes to a concrete facility where it's made out of where concrete is produced. Then it's used in buildings. Then it gets demolished, and then it goes to a waste collector, and we reuse it. And like those codes you see here, like A1, A3, they are actually part of the life cycle analysis building information model. And yeah, in the disciplinary idea behind this project, it's actually the idea that really environmental engineer can calculate the environmental impacts of these flows. For example, I made like a quick calculation of how much carbon is emitted by the production of concrete, and for this scheme, it's 25 million tons of carbon which is emitted because of our demand for concrete in this region. Yeah, and it's actually that building life cycle information that I thought, but this is quite important because then you can see, okay, how can I achieve circularity and reduce my demand? But it's also quite, there's not a good link between this and urban design, but it's quite important in order to reduce the material demand. Yeah, and on the other hand, when we talk about circularity, we also talk about which is actually a goal we need to achieve in order to reduce our material demand, and to make this metabolic system more circular. You also have like a way or hierarchy to how to use our material. So, and there, how we use like our primary materials, or our inflow and our outflow, our waste, they're quite similar. Here on the top are the best options, so it's the best to prevent actually waste or material. The worst option is that we dispose or our outflow, or that we actually use linear consumption. So we want to avoid that. Yeah, still this is quite not that easily useful in urban design, but during my research I saw some methods which actually shows like how we can use this conscious idea of material usage in urban design. And it's actually based on the situation conscious approach of Bijhouwer. He needed to make a design for the Ketel region next to Schiedam, and he looked at the soil map quite clearly on, okay, what are the best suited locations to build houses. So then he knows, like, okay, when I build houses here, then it's quite bad soil. So then I need a lot of fill sand to prepare it, and it will eventually subside, and so on. And to actually have this like this conscious ID also in our urban design approach, I made it a material conscious approach. So when we need to have design for an urban environment, then we look over the entire life cycle on when material in and outflows happens and how we can alter that. And on those flows, you want to apply those 3 strategies of prevention, reuse, and recycle. And in my design, which I will show in a moment, I look at like an urban design from over the entire life cycle. So you have the situation, your designer, the maintenance during its lifespan, eventually the end of life scenario. And here you can see where material will happen. It is quite more complicated, but so if you have any question, you can ask them afterwards about this. But what actually is important is that you can see here, like, okay, I've got an idea to build something, let's say this amount of houses, then my concrete comes from a concrete faculty in the region, and the material is actually mined somewhere behind. And here you can actually, here you can visualize and guess the material flows which happens behind your designs. But I've got some examples of how it's used, so then it will become clear. So yeah, will become clear in a second. But in order to really reduce sand consumption in urban design, I was searching for solutions, and our catalog of solutions, which was like an appendix of my thesis. That's something that people do a lot in the urban metabolism studio, because there you look like, okay, what are options to really change this material flows in our urban design through urban design. And yeah, these are all the possible solutions for urban design, which can actually reduce or prevent sand consumption, reuse sand-related materials, or actually recycle it. And I will show some examples. I will show 3 examples of how it's actually, what those solutions actually are. So, for example, we can reduce our demand for sand by building on water, because then you don't need fill sand to raise your site under your buildings, and then you actually prevent sand consumption. So that's one option. Then we can reuse old buildings instead of demolishing them for residential buildings, like this example from the Philips factories in Eindhoven, which they transformed into residential areas instead of demolishing them. And the last one is actually make use of secondary sources. For example, recycle concrete in new concrete, or in the context of fill sand, you can use recycled EPS, that's a plastic, in order to raise it. And it's a lightweight material, so it doesn't cause subsidence that much. And you can use it from secondary sources, such as insulation materials from demolished buildings. And this actually shows like all the solutions applied on a specific urban development. So, for example, this transformation of buildings, it can be done in a transformation of non-residential areas. Building on water can be done in greenfield development, and so on. So this gives like a nice overview of those quite metabolic solutions of how you can alter the flows in the system, and it's translated to these solutions which can be applied on urban design topics. And the last part is that I applied those this method of material consciousness and those solutions on places and locations in the region. And I choose, yeah, these are actually all the locations that I have chosen where each different kind of urban development occurs. So here, this is an area in Rotterdam where they wanted to transform a residential area into a non-residential area into a residential one, where subsidence occurs. Here next to Spijkenisse, there's an area where they want to build houses on a green field, but also where subsidence occurs. And I will continue on this one to show how I applied those solutions and the methods. So these are actually all the the designs which are related to this material conscious approach. And maybe nice to mention is that you always want to make those really nice and realistic images at the end of your design, but I choose like a method which suited me the best for my design method. So I needed to make like several options of all the designs, and instead of spend nights photoshopping everything quite realistic, I used just those sketches where I can easily make changes by putting like another tracing paper on top of it and make some changes. And yeah, for me that works quite well, but it did that different for everyone. So like try to achieve, it isn't the goal to try to achieve like this most realistic image. Just choose like the visual technique which suited you the best, and yeah, in your project, but also in your skills. So yeah, this is a part of the methods. Yeah, I'll skip this. And this is how how eventually the sand metabolism on a regional scale should work. So yeah, when you have a new construction, then you can use like bio-based material or recycled material. Yeah, this is also quite a little bit too detailed for now. I will just continue on the design part. So here in Spijkenisse, they wanted to construct a new neighborhood in this area. So now it's just green fields. But it's also, this shows like the soil type, so it's peat, and that's weak soil. So when you put sand of it and buildings on top, then it will subside. And in this method, I first make business as usual design, so how we usually do it, and from that I make alterations with my solutions from this catalog to see if I can really reduce the material demand. And this is also the part where this scheme will come into play. So this is like the business as usual design. To be honest, because for the sake of the graduation research, just a little bit copy paste of another place or an example of a design. So not much of design part of it in this. But just to give like an idea, okay, when we develop here, it looks a little bit like this, and a little bit Phoenix-like. And this design, there isn't currently a situation, so there's only material required in order to build this image. A lot of fill sand in order to raise it, then concrete and asphalt in order to build the constructions. Over its lifespan, there needs to be some maintenance because the roads subside. And at the end, demolished everything. And here you can see that, the materials is mined from a material from its source somewhere in the Netherlands and beyond. Then somewhere in the region, there's a concrete facility which makes concrete, and that flows to the area where it's built. And based on like this image and this image, I made some changes in the design of how we can reduce this material demand. So the first one is by trying to reduce this big flow of sand, which is required to raise it by putting all the house on piles. So actually make them a little bit float above the surface. So there was one of an idea. So you don't need to change like the area below from the current situation. Also to make the neighborhood a little bit smaller, so there isn't any front yard, but everything is like in the back, and the roads are made out of EPS in order to make lightweight material, and the concrete is from the urban mine. So what you saw in the beginning in the calculation of the metabolic system. So there's a lot of concrete demolished. Instead of using it for foundation, we use it for new buildings. Another idea is to, instead of using this green fields, we're gonna densify the current area in order to put all the buildings there. And here, I forgot to mention, but here you can see in this impression also some qualitative indicators on how this idea differs from the other one. For example, now it's greener here, but there will be less green in the neighborhoods, and the public-private situation will change. And here you see then how it works. So there will be some building demolished here, where there's an outflow, and you reuse it from this outflow and in the new building, so they will be more materially efficient instead of the old ones. And at the end, those buildings will be demolished and you will reuse it again. And the last one is that everything is on piles, and it's like a platform above the landscape, and some floating houses. And then you can see that these are the changes that happens on the sense of material consumption. So when you put all those schemes together, you can actually evaluate like, okay, I've made some urban design changes, it looks differently, maybe not that nice, because when everything floats above wetlands, then you will get a lot of mosquitoes. When you have children and they fall into this wetlands, that will be disastrous. So, but I kept those things out of my scope, because you only have for like 1 year. You need to be quite clear. Okay, I have like 1 year. I will do this, but I won't do that. It's also good to mention that explicitly. But here you can actually see, okay, those designs actually reduce the material demand, primary material demand of sand. Like theoretically, it all comes from the region, but on a regional level, you still need some changes, and you need some places there as well where you can actually recycle your concrete, or where you can clean the soil, because sometimes the ground is also polluted. And that creates like these landscapes, which is like the last part on how it works on a regional level. So some soil needs to be treated. You can use like the wastegapes around infrastructure in order to create these landscapes. Another part is that you can use the sediments from the river as tidal parks, but maybe also as a substitute to fill sand. And another one is to use fresh material and treat it in these clay ripening areas and plots, and it can also eventually be a substitute to fill sand. So this is like a step higher, and eventually this also alters the material consumption on a regional scale. So this is the first one of the there's actually the metabolic system that I showed after my analysis. And here you can see how much is reduced. So for example, from all the different ideas of reusing and concrete, you can actually reduce up to 90% of sand, and by using those tidal parks and land farming, clay ripening areas, you can actually reduce 25% of dredging. So that's actually like the end image, and this actually shows like how urban design can reduce the demand for primary sand and gravel in the region, and eventually this actually shows like how much we can use. So there are like two methods of recycling. You can recycle 100% of your concrete, but then you still need like 70% of the demand needs to be from something else. But when you do it like for 90%, then you still need 10% primary material, but then you don't need that much. This is actually a part at the end where I made a discussion of how much what's feasible and what's not. And for EPS as plastic, in my design and calculation, I made a demand for EPS. So I say, okay, we can put EPS there, and we can put EPS there, but the amount of material which is available from demolished buildings, like the EPS, it's only 1% of the demand. So this is actually a bit background of that, how circularity and urban design links together. Like you can say, okay, that there's like a certain boundary to your amount of materials that you can use in order to achieve circularity in your region. And eventually, this is like an end image. You will get this connection in a region where all those ideas are linked together in order to get a sand balanced region. And it is like my final image of the of my presentation and also my thesis. But I made this image actually at my P2, so after half a year. And that's actually also some tips I want to give to you at the end. That it's actually my fourth tip that I will start with, that you need to draw like your thesis work from the beginning till the end. So you need to you have an idea. Okay, I want to achieve that at the end of my graduation year, but you already know like what you need. So you can when you have like a certain goal like this. Linkage in the region where you can like reuse material from one to the other, you can already draw it. Or if you know like a certain technique which you want to use, but you don't have like the correct information, you can already do it like a sketchy or a method on a method. And that really helps like your mentors to see, okay, what do you want to do and how can you use with that. Other tips that I have is that you need to choose a topic or locations which really will inspire you for an entire year. So that's something to keep in mind. And what helped me a lot was that I saw my graduation as a 9 to 5 job. So I went to the faculty at a certain time and try to do it like a normal job nowadays, and that really prevents you from those night works during deadlines. But also gives you the time to go to the bow pub once in a while. And it's also good to always brainstorm and discuss your work with co-students for inspirations, and it really helps you a lot when you're stuck with something. And what helps me as well was that I made more deadlines than necessary. So you have those P1s and P2s, but I also made some more deadlines with my mentors in order to really finish some works, because this analysis part I could do like an entire year to calculate everything. But my mentor said that no, we need it at that date, and then we can continue. And it's better to do that as well next to the PU1, 2 midterms and so on. So thank you for listening, and good luck next year. And if you got any questions or about the topic or and so on, you can don't hesitate to send me an email on this address. So thank you for listening.
Thank you so much, Wouter. It was really interesting and intense thesis. So we have like 10 more minutes for discussion as well. So Maud has a question already. Maud, do you want to ask it yourself?
Yeah, that's fine too. Okay, so I already typed my question in the chat, so if you like to read along, then you can. Thanks a lot for the really interesting systematic presentation. Yeah, I was wondering, what have you learned yourself during your graduation? For me, it seems like you knew what to do the complete time, because it's really well thought through. And I really liked it that your sketches in the beginning were super rough, and in the end they were quite concrete. So it seems like, yeah, you thought of that in the beginning and then went through it, yeah, real systematic. So was just curious what you've learned for yourself.
Wouter, we can't hear you.
Sorry. Can you hear me now?
Yeah.
Okay. It's funny that you said it, because I got like a pile of sheets and sketches that I didn't use at all. But what I found nice is that you have like this method part that you need to develop during your graduation. And some people see it that it's like separated from your graduation, but you really need to integrate this methodology course in your entire project. So this your method, like how you will do it, what you will do it, that's actually like your base, or your, let's say, a tree of your entire project, and you can put like a lot of things on it, and so it will like contribute to your end goal. So a tip would be that you really need to discuss with your mentor, like, okay, what is my structure, what is my method, and I will choose this method, and how will this help me in my further research. So because there are also some mentors which see it separately, and that don't just think about like, okay, deep more into the theory and just do just keep on researching, but you really need to make a structure out of it.
Okay. Is there space for like one small extra question then?
Yeah, sure, go ahead.
Okay, yeah. Okay, thanks for the answer. And then my question was, we just had the speed dates for all 5 studios, and I'm doubting to choose this one because I sometimes get lost in the process, and I think this studio is a real systematic one. Is that right? Like, do the teachers really help you to in the end and during the whole process come back to indeed that model you were talking about, and to your method and conceptual model, and your the one that you used for the one with the arrows, in which you defined the flows.
The material flow analysis.
Yeah, indeed. Yeah.
Eventually all the mentors from each studio will eventually look at your method and structure on what you said in the beginning, and if you really answered your research question. But in the urban metabolism studio, you grasp like one part of this urban metabolic concept and then a material. So there are people who focus on energy or water or food or yeah, all those things. And in the studio, yeah, you just look at this metabolic system of how it works, and you're going to alter things in that. So yeah, you can say like when you don't alter anything through your design, then you haven't really achieved your goal, because most time there's something wrong in the urban metabolic system. For example, with water, there's a water shortage or drought or too much rainfall, and you can really show that in this metabolic system, and there you can alter things through urban design, and that really helps you with understanding the system and to see where solutions should occur and where not. But on the other hand, my second mentor was from civil engineering, so there was quite a technical part of it, but most of the people from urban metabolism have a second mentor from inside the architecture faculty. So then you get linked with with more maybe social social consequence of your urban metabolic solutions. And then becomes more vague. So then
Yeah, get it. The technical part, like the civil engineering part, kept it clear from beginning unto end, because it was just one flow, just to call it like that, or one topic: energy, water, food. In your case, sand. And because of the technical approach by civil engineering, you could stick to the really clear process. Yeah. Okay.
Yeah.
Thanks. Yeah. Thanks.
Thank you. Maybe I have one more question. I see that the thesis has a huge portion of trying to understand the existing situation as well, right? In terms of life cycle analysis and what the existing cycle of sand flow is. So could you sort of tell us the split between the analysis part versus the design part, in terms of like what is the studio focuses on? Is it more about getting a clear picture of what's there, or like creating new solutions?
Yeah, I think like the design part was quite there was a more focus on the analysis part, because yeah, you needed to understand the system, and the design part went actually quite quickly, because it was quite a methodological approach. Like, okay, I have like these steps, and I just do it like quite like a machine, like okay, make everything and then compare it. So I think, but then on the other hand, those research on solutions was for longer periods. So I think that those two went like parallel. So it was, I think, let's say 5 months with the analysis of the current system, but that was also theoretically, and then also the results and interpretation, and at the same time checking and researching the solutions, and for 2 months maybe making designs, and but in the end, I found it a little bit a pity that I had more time to work on the designs, because it was quite part of a method where you just I think I showed quite a little bit quickly on how this design structure works, and because of that it was quite quickly, but it would be really nice to really continue. Okay, how can you really do more things with designing, because I also found that the way how you create urban blocks also has an impact on how much material you need, because when you have like 2 buildings, then you have like 2 load-bearing walls, but when you put them together, then you only have 3. So there was quite complicated, but a lot of the actual design part. But yeah, then in the end, you don't have that much time anymore to do everything. So in the beginning, I knew that the design wouldn't be that much of a part of my research.
Okay. That's specific to your project, or is it the general direction of the urban metabolism study?
It's actually a lot of graduate students counter this problem. So they keep on researching, and because you want to gather all the information, you want to have like a clear image of how it works. But yeah, you will be a master of this topic, but you won't know anything, because it looks like that I know everything about sand, but there are still things that I still don't know how it works. So yeah, you really need to make a deadline together with your mentor. Okay, I want to have like maybe 50-50, or I want to put my emphasis on design. Then you should mention that quite early, and then you need to see, okay, how can I already integrate it more earlier in my design, or when do I really need to stop doing all the research and start making designs and forget everything that I learned afterwards. So that's something that you yeah, that you need to keep in mind, and also make a good promise with yourself. But you see that a lot of students keep like researching until yeah, before. It's like, oh wait, I've got one 1 week left and I still need to make my design, and then yeah, it's a lot of stress. It's a common mistake.
Do we have any more questions from the audience? Okay.
Can I ask a question? I actually
Sure.
have 2 small questions if there is still time. Yeah, thanks for your presentation. It was really interesting to see an end result of a thesis. My first question was, how did you come by the topic of sand? Was there like a special trigger where you thought, right, this is something I'm going to dive in, and yeah, that took your attention? And the second one is, I see that you made a design or an approach for a specific region. Did you have contact with the Drechtsteden and Rijn? I'm not sure which one it was, but did you have contact with the municipality or other actors, which were involved in your thesis, or did they know something about that you're working on it? So maybe a relation with the work field.
Oh yeah, yeah, that was a good question, because I haven't actually told the answer of the second one, but I will answer your first one first. I did some multiple projects concerning construction material and metabolism during my master's. So yeah, I did during my elective, I did, I think, a geodesign course of Ulf and Alex, and they already made a design or a project which was with the topic construction materials, and that was quite a thing that fascinates me, like how there's this big ambition of circularity in the built environment, but somehow urban design is out of the fields, and it's also something that lives inside the faculty. Like when you say, okay, I want to do something with circularity of construction material in the urbanism master, they say like, no, you shouldn't do it. You should do it. That's something for the architecture people, but that's quite strange, because like a building can't really change this this entire supply and demand and circular economy for the built environment. So that's like a general struggle. So I was struggling a little bit with this topic, and actually quite broad, like construction materials, circularity in general. And then I think Fransje Hoijmaier sent me like, oh, if you want to do something with material, then I found this article on scarcity of sand, and then it was like, okay, that's maybe something to pick up. And I think like the first month I didn't know what to do. I had like really a lot of ideas on different topics, and yet like in the beginning you can still choose which studio you want to do, and I know that I was sitting with Ulf, my mentor, that I said like, oh, I want to do this and this and this, and then at the end I said, yeah, or maybe something with sand, and he was like, what are you gonna do? So and somehow I just developed it a little bit, and it got stuck, especially with those really fascinating and intriguing news articles. So it's somehow, it wasn't that it wasn't the case that I knew it like from the beginning. Oh, I want to do this. It was somehow developed, and somehow I got stuck with it for an entire year. Yes, it's also good to have like multiple ideas and just discuss it with a lot of professors, or mentors, or students. And
in what time frame did you decided, all right, this is the thing? Because you mentioned that you struggled for over a month or something, or
something like that. So you have like when you start your graduation, you have like first month you need to make like a draft proposal, and there you can make like multiple ideas. And yeah, I think during that period it was still a little bit fake. But I think until the part that you really need to choose your studio, it was still a little fake on what I wanted to do. So but you really need to like let's say this news article and statement of that sentence becoming scarce. Yeah, I just showed it also to professors, like, oh, I want to do something with this, and then they say, okay, yeah, let's see what you can do with that.
That was your opening.
Yeah.
Okay.
Also nice anecdote.
Yeah.
I think I even made a comic on there's this English saying of selling sand to an Arab, which means actually that you can sell everything to everyone. So I made like a comic of that, and then you saw next slide, you saw this news article of Dubai buying sand from Australia in order to build the towers. That's like, it's quite something that just attracts the audience, but also your mentors. So
right.
And the second question, I somehow got in contact with Peter van Velen via other employees of the faculty, and in the beginning I wasn't quite sure on which location I wanted to do it, because the topic is you can do it all over the world. So, but I got in contact with Peter van Velen. He has an office, and he was a former mentor, professor of the faculty, and he is working on the design living lab building with sediment, and that's actually a consortium of Deltares, the research firm, municipality of Rotterdam, the harbor of the port of Rotterdam, the municipality of Dordrecht, and they are just for the international architecture Biennale of Rotterdam. They're doing this living lab, and somehow I got in touch with them, and they said, okay, there are multiple students who were involved with this. You can just make your location Rotterdam and Dordrecht, and they can become part of this consortium. And that's how I got in contact with people from the municipality of Rotterdam, and also with Deltares, who just give me like data on, okay, if you need to know this information, then you can go to this website, because they publish everything. And I think I will show you the website of Peter van Velen, because I don't know if he's still doing this research. But if you want to do something with sediment in this region, for example, tidal parks, then I will send it in the chat. Like, this is his this is his office, and I think you can contact him and just say, okay, are you still searching for students for this building with sediment living lab, and then you can get in touch with all those different companies, for example, municipality, which can give you information. But it's also nice if you want to do something more interdisciplinary with the faculty of civil engineering. So if you are planning to do transitional territories, then it's maybe also interesting to look into this. And Fransje also knows more about this, I hope, if she hasn't forgotten. Yeah, so that's how I got in touch with multiple offices, and also just email them or call them. It's like, yeah, I think also for this first diagram that I showed with all the materials used for and extracted in the Netherlands, one of the first slides, I also just emailed the guy who made the entire research, and he will just respond. And yeah, it's actually strange that they don't encourage or promote that on the faculty. They just can call the people who made it, and yeah, if you don't have time, then they won't answer. But most of the time, they just are proud of what they made, so then they want to brag about it or something. So yeah,
that's also a good tip.
Yeah.
Thanks.
All right. I think we are a little over time now, but thank you so much, Wouter, for your presentation and for taking the time to answer these questions. And we've recorded this whole session. We would upload it on YouTube as well. So if you want to like revisit some of this, you can. But thanks again, and I thank everyone who made the time to join today. Yeah.
Yeah, thank you as well for inviting me.
All right. Have a good week. See you.
Hey, yeah. Good luck with graduations.
Thank you. Thank you.
Bye.
Thanks a lot.